Hello and good morning or good afternoon. I wanted to hop on here real quick and do a quick video on the order of operations. All right, we're actually going to do this a different way. We're going to look at it with blocks. And I wanted you to watch this video before you started trying the activity that you have on your paper in class. So here we go. We're going to start real easy. You all are going to be like, oh man, Mr. Cox, this is so easy. I don't even need to build it. But I want you to do it because as these get harder, the building part becomes more and more important. All right, so we're going to start real easy with a number like the number 4. All right, so with your block, all you're going to do for that one is you're going to pull apart 4 blocks. Okay, that one's real easy. All right, so anytime you have a whole number like that, let's say 5, I would just add in another block, 5 blocks, right? That's it. That's it for when you have a single number like that. All right, now from that, we're going to move to something like 2 plus 4. Another form of writing an expression there. Okay, so for that one, you're going to pull 2 aside, and then on your paper, you're going to put a plus sign in the middle here. Oops, let me slide that over a little bit more. All right, so you're going to have 2 plus 4. Okay, we know that 2 plus 4 would be 6. But I want to make sure that you draw and you pull that separate like that, just to show the steps needed to get there. All right. All right. What if I did 8 take away 5? Okay. Well, then you're going to start with 8, 2, 4, 6, 8. Notice these are still all separate, right? Because I haven't started to connect anything together yet. You'll see what I mean in a second. There's 8, and we're going to take away 5. All right, so on your paper, what you would do is you would take and you would cross off 5 of these. All right. The way that I'm going to do it now with my blocks is I'm going to take away 2, 4, 5. Right. So take away 5, and then I'm left with 3. All right. So again, important to build it with these blocks. All right. I know it seems kind of silly right now, but it's going to be important here in a little bit. All right. The next type of expression would be multiplication. All right, so if I did a 3 times 2, the word that I want to start clicking in your head for this is an array. All right, so when you do a 3 by 2, we're no longer going to have cubes that are separate. We're going to now take the time, right, and we have the time to do this, so let's take the time and do it, to build an array. All right, so I would clip these together, and you guys have your own blocks that you can use, right? And there, that would be a 3 by 2. And we know that 3 times 2 is 6, and that kind of agrees there with having 6 cubes. All right? Just to be clear, this 3 by 2, we're going to treat different than just 6. Like we just said, the 6 means that the 6 cubes are going to be individuals. Okay? So make sure that you kind of understand that. All right, now the reason why this is important is because now we're going to start looking at something like this. 4 times 2 plus 3. All right, and what I want you to recognize immediately is that we need to build an array, that 4 by 2. What you'll learn eventually is that with order of operations, you want to do your multiplication first. All right, and if you start thinking array now, then you can start, getting that to kind of sink in a little bit and become something that's natural. Like you just do it because you know that that's the first thing that needs to happen. Okay? So I am doing that. I'm taking the time to build, we'll see it in a second here, a 4 by 2 array. There it is. So on your picture, you'll draw that array. You're going to write a plus sign and 3 individuals. All right? So the idea here is that you recognize we're not doing 2 plus 3 first because it's easier. We can't do that because the 2 is locked up as part of this array, which means we have to do multiplication first. Okay? So we would know that 4 times 2 is 8, and then we would do 9, 10, 11. So this is how I want you to draw it on your paper there. Okay? Now, the next layer of problem is going to be something like this, where we flip it the other way. Let's do 2 plus 5 by 2. I guarantee a lot of you are going to see this and you're going to go, easy. 2 plus 5 is 7. 7 times 2 is 14. And I'm going to tell you right now, that is wrong. It is wrong. You have to do your array first, which is the whole purpose of doing this block thing, okay? So, if I have a 2 by 5 array, like that, and I know that I'm going to add 2 more to it, I can't add 5 to my 2, because that 5 is locked up in this array. I have to do that part first. 5 by 2 we could count quickly by doing 5 times 2. We know that 5 times 2 is 10, plus these 2 would be 12. Alright, so the answer to this, as you can count here, would be 12. Right? We can't do this 2 plus 5 because that 5 is committed to this multiplication first. Okay? Alright, last thing. Promised I would keep this short, and I'm going to do my best to do that. There are these little numbers called exponents, and they look like this. Okay? And boys and girls, that is a fancy, fancy way of writing 3 times 3. Alright? That number right there means that you want to build a square. In fact, that's actually called 3 squared. Right? That's where that name comes from. So that means that you want to build an array, but that array just happens to be a square. Right? Nothing too fancy about it. It just happens to be a square. So let me finish building here. And that's what that would look like. Alright? That little exponent, we call that an exponent, means that your shape needs to be a square. Now sure, we can do 3 times 3, and we know that this total is going to be 9, right? But the easiest way to think about, a lot of people look at that exponent and they want to say, oh, 3 times 2. But it's not. Okay? That 3 squared means you need a square whose sides are 3 blocks long. Okay? Another example of that could be, I'll add another layer of difficulty here, 4 squared plus 2. Okay? I don't want to do 4 times 2. I know that that's not what that means. And I can't do 4 plus 2 yet here, right? Because this 4 is committed to this array, and this array just happens to be in the shape of a square. Alright, so I'm going to need to add some cubes here. Let me do that real quick. Oh boy, I hope I have enough. I think I will. Get a couple more out of my box of blocks here. And as you've noticed, it takes a little bit of time to build, but it's important for you to understand why we're building and what this thing would look like if you were to take the time to build it. There we go. See, that wasn't too long. So there's my square. Squeeze that together. There we go. There's my square. It's a 4 by 4. And again, it's really easy to see. If I did 4 times 2 right here, that would give me 8. And boys and girls, do I have 8 blocks there? I do not. I have 4 times 4. Right, a square that's 4 by 4, which gives me 16, and then I just happen to need to add 2 more on the end, right? There's my plus 2. Alright, so 4 times 4 is 16. 16 plus 2 would be 18, and that would be your answer there. Okay? So, that is just a brief introduction to the order of operations and kind of how we need to work these problems out. The problems do get a little more difficult. I'll do one more here for you just to show you full course all the way through, kind of what we're going to do as 5th graders. You might see something like this, and again, I'm just going to kind of make this up quickly. 2 times 3 plus 2 squared minus 4. And that's really longer than we'll have to do as 5th graders, but let's face it, you're a month away from being a 6th grader, and I know for a fact that you're going to do problems like this in 6th grade. So we're going to get an early start. Alright, so to model this, I always start with my exponent. Everybody say that with me, 2 squared, which means we're going to do a square that just happens to be 2 by 2. And again, this is, you can go back and pause this and watch it as much as you want. Alright, there's my square. I hope that we recognize that as an array, a 2 by 3 array. So let me get that for you real quick here. Alright, there's my, oh, I guess I'll put it in the correct order there. Okay, so there is my 2 by 3 array. And again, so I wouldn't add this 3 and this 2 because 3 is locked up here, right? And the 2 is locked up in this thing, so you can't take them apart and shift them around. Now, after I do that, I'm just putting these here as a reminder that I need to take away 4, right? So my minus 4 is going to be at the end. So let's do that. My 2 by 3 array we know would be 6. My 2 by 2, 2 times 2 is 4. So 6 plus 4 would give me 10. Holy moly, I better write this down. And then at the very end, I'm going to take away 4, right? So minus 4. Well, if this is 10 and I need to take away 4, that's easy to remember here. I'll just take these 4 away. All right, so I'm going to I started out with 10, and I'm going to take away those 4. I busted them up into individuals so that you recognize the difference between our exponent and our individuals, right? So I'm going to take away those 4, and that's just going to leave me with that. So my answer for this all the way through would just be 6. All right? And again, that last problem is probably the trickiest one that we're going to see in 5th grade, even if that. So the other ones that we did before that are a little bit better indication of what you're going to be asked to do as a 5th grader. All right, as always, if you have questions, let me know, and I will see you guys in the classroom.